In this lecture today, we want to look at fundamentals of chemistry. We want to see how chemistry is viewed from a matter to an atom, then an element, compound, and we shall look at different definitions and structures. Then we are going to look briefly on the first 20 elements of the periodic table. As we begin, if it is your first time, please go to where there is a subscription button and subscribe. Then like the video, and even after you have enjoyed this lecture, you can share to many others. So we want to look at the fundamentals of chemistry, whereby we are going to begin with what is a matter. And matter is anything, we have been saying that matter is anything that occupies space, and has weight. So long as something can occupy the space and has weight is what we know as matter. And matter can be either a liquid form, it can be in solid form, it can be in gaseous, it can be a gas. That is what we call matter. Then an atom is a smallest. This is a smallest indivisible particle. It is the smallest particle. And this smallest indivisible particle is made up of, it has a nucleus. An atom has a nucleus, and within its nucleus, it contains what we call protons and neutrons, whereby protons in the nucleus of an atom are positively charged, neutrons are positively charged, whereas neutrons have no charge. So within, if I can draw a simple structure of an atom, and this is the nucleus of this atom, then it has the energy levels. We're going to see within the nucleus of an atom, we have there what we call neutrons and protons. And we have said neutrons, they have no charge, whereas protons are positively charged. Then along the orbit, that is along the energy level, we find there electrons. So along the orbit, we find electrons, and these electrons, they are negatively charged. So they are found along the orbit. So you find here we have electrons, and the first energy level, the first shell accommodates only 2 electrons. Then the second, the third, and so on shells, they accommodate 8 electrons to be fully filled. That is what we are calling an atom. So if it is the second shell, it accommodates 8 electrons, but you first have filled, then you come and fully fill. So it has 8 electrons. If I can add the third one, the third energy level, this atom still is going to have 8, but you first have filled the orbit, then you come and fully fill. And when the energy level of this atom are fully filled, they are unreactive. So these atoms react when they lack or when they are not filled, when the orbit is not filled with electrons. So if you have an atom with the number of electrons 2 in the outermost energy level, that is neutral, that one is unreactive. If you have an atom with 8 number of electrons in the outermost energy level, is also unreactive. For example, neon, argon, and helium are examples of unreactive, and we call them rare gases because they have a stable electronic configuration. That's why we say they are unreactive. So for a compound to react, it must be either lacking or having little number of electrons in the outermost energy level. And that's how we can use them even to determine the valence. And after looking at what an atom is, we can also define what an element. And an element is a substance, any substance containing one atom. If a substance contains a single atom, is known as an element, and this one cannot be separated by physical means, only separated by chemical means. That is what we call an element. So an element is a substance containing only one atom. So meaning elements, they contain neutrons, protons, and electrons. So they also contain neutrons, protons, and electrons. Proton is positively charged, electron is negatively charged, and these ones have no charge. So that is what we can call an element. And an element, they always have electronic configuration. For example, if we're going to look at the elements, then we are going to go to what we call electronic configuration. And according to the periodic table, the first 20 elements, I remembered using this mnemonic which says Henry has little brothers, and these little brothers both cannot organize for night studies, may all sleep peacefully, since children are passing chemistry. That is the mnemonic, whereby Henry stands for hydrogen. This is hydrogen. Then has stands for helium. Little stands for lithium. Brothers stands for beryllium. We have beryllium, which is abbreviated as Be. Then we have boron. Then we have carbon. Then we have nitrogen. Then organize, this is oxygen. We have fluorine. We have night. This is for neon. Then the studies, that is sodium. Then this is magnesium. This is aluminium. Then we have silicon, the number 14, that is silicon. Then this is phosphorus. Then we have sulfur. This is sulfur. Number 16 is sulfur. Then this is for chlorine. Then this is for argon. Then we have potassium. Lastly is calcium. So these are the first 20 elements of the periodic table, whereby we are saying Henry has little brothers, both cannot organize for night studies, may all sleep peacefully, since children are seriously passing chemistry. So we can use this mnemonic to remember the first 20 elements, whereby we have from element 1 up to element number 20. And these elements, their atomic number is determined by the number of protons within the nucleus of an element. So we are going to tell you that the atomic number of an element is the number of protons. This is the number of protons in the nucleus of an atom. And these numbers, number 1, number 2, they are determined according to the number of protons. And I want you to remember, you note that number of protons is always equivalent to number of electrons. That is what you should note, that if I have 6 as a number of protons, even electrons are also 6. So they have the same number. Number of protons are the same as number of electrons. So if I can ask you the atomic number of calcium, that is 20, because it is in position 20 in the periodic table. If I can ask you the atomic number of sulfur, that is 16, because it has 16 number of protons. If I can ask you the atomic number of oxygen is 8, because it has an 8 number of protons. So the atomic number of an element is determined by the number of protons in the nucleus of an atom. So after knowing that maybe oxygen has atomic number of 8, I can easily draw its structure, whereby its electronic configuration, the electronic configuration becomes 2, whereby the first shell is accommodates 2, then the remaining is 6. So the second shell will accommodate 6. So this one becomes its electronic configuration. If I can draw its structure, you'll find we have neutrons and protons within the nucleus, and the first one accommodates 2, and the second one accommodates 6. But you first have fill, then you fully fill. So this one becomes the structure of oxygen. If it is the structure of potassium, which is, this is potassium, and potassium has an atomic number of 19, so the electronic configuration is 2. Then the second one, we said it accommodates 8. Then this is 10, so we are remaining with 9. But it cannot accommodate, so it will be 8, then 1. That is its electronic configuration. So to draw its structure, the first shell with neutrons and protons accommodates 2. The second one accommodates 8. And we first have fill, then we fully fill. The third one also accommodates 8 electrons, which are negatively charged. Then the last one accommodates only 1. So this is its structure. Then the electronic, so you can easily get the electronic configuration if you know the atomic number. And atomic number are determined by the number of protons within the nucleus of an atom. And after knowing this, I can easily even determine the valence, whereby we are going to tell you that valence of an element. What is the valence of an element? Before we go to the atomic mass, we can even still first tackle valence of an element, whereby valence of an element is the combining power. This is the combining power of an element. So the combining power of an element is how many hydrogen bonds are formed by an element during reaction. And this valence is always determined by the outermost shell. Is determined by the outermost shell or orbit, which either can be the number of electrons in the outermost energy level or the number which during bonding, because the valence, the combining power, is the one that gives the bond. So during bonding, how many electrons are shared or lost is what determines the valence, which is determined by the number of electrons, either which are there or which are lacking to fully fill, to form a stable electronic configuration. So for example, if I can ask you the valence of oxygen, which we have here, it has 6 number of electrons in the outermost energy level. But its valence, valence of oxygen has a valence of 2 because it is lacking 2 electrons to fully fill the outermost energy level. Whereas the potassium, for it has only 1 electron, so it can easily lose the 1 to attain a stable electronic configuration of argon. But this one, to attain a stable, it needs 2. That's why we write oxygen like this, because it is reacting by gaining 2 electrons. That's why its valence is 2. But potassium, because for it, the energy level, outer energy level has 1, it reacts by losing 1 electron. That's why we write it like +1, but its valence is 1 because it has only 1 electron in the outermost energy level, which during a reaction it reacts by losing, whereas oxygen reacts by gaining. So in a nutshell, we're going to say that metals, elements which are metals, react by losing electrons. And because they react by losing electrons, they attain a partial positive charge. They attain a positive, because if you donate, you are credited. So metals are like men. Men react by losing. That's why we are strong to attain, and we are always respected. That's why we are given a credit. So metals react by losing, whereas non-metals, elements which are non-metals, like oxygen, for them they react by gaining. These ones react by gaining electrons. And because they react by gaining, they attain a partial negative charge. So metals are positively charged, whereas non-metals are negatively charged, because metals react by gaining, by losing, whereas non-metals react by gaining electrons. So I've told you valence is the combining power, which is determined either how many electrons a non-metal gains to form a stable electronic configuration, or how many electrons a metal loses to attain a stable electronic configuration. That is what we can discuss about valence, which is the combining power of an element. Then this one shall lead us into what we call isotope. You need to know what an isotope is. And an isotope, this is an elements. You find elements, and these elements having same number of protons but different number of electrons, but different number of neutrons. So elements with the same number of protons but different number of neutrons is what we refer as an isotope, and they are chemically different. That is what we call an isotope. Same number of protons but different number of neutrons. Then the next thing we are going to look at is atomic mass, or what you can call mass number. Atomic mass is the sum atomic mass is the sum of number of protons and neutrons within the nucleus of an atom. So if you get number of protons, you add neutrons which are found in the nucleus of an atom, you get what we call atomic mass of an element. For example, if the number of protons of oxygen is 6 and the number of neutrons is also 6, to calculate its atomic mass, you get number of protons, which is 6, plus number of neutrons, which is 6, you get 12. So you get the number of protons plus number of neutrons to get the atomic mass, or what we call mass number of an element. That is how we can always get. Whereas to calculate the atomic mass of, maybe the atomic mass of sodium has the number of protons is 11, then it has number of neutrons is 12. So the atomic mass of sodium is equal to 11 plus 12, which is equal to 23. So the atomic mass of an element is the sum of number of protons and neutrons within the nucleus of an atom. When you get the number of protons, number of neutrons, you are able to get the atomic mass of that element. After looking at that, we need to know what a compound is before we end our discussion of today. We should know what a compound is. And after knowing what a compound is, we are able to calculate the molecular weight. So we can end our discussion by looking at what is a compound. And a compound is a mixture of elements. If you get something having more than one atom, so a compound is a substance containing more than one atom, or it has greater than one element, because we saw elements have a single atom. So that is what we call a compound. So it is a mixture. It is a mixture of different atoms or elements. That is what we call a compound. For example, a compound can be, if I get hydrogen plus oxygen molecule, I form a compound known as water. So water is a compound. Or if I get carbon plus oxygen, I form carbon dioxide. This one is a compound, whereby I'm getting carbon plus oxygen molecule. So that is what we call known as a compound. Or if I can get sodium and I add chloride, I form sodium chloride. This is a compound. A combination of two elements or two atoms is what we regard to as a compound. So after knowing a compound, I can easily calculate its molecular weight. Molecular weight, whereby molecular weight is the sum. By calculation, it is the sum of atomic mass of elements in that compound. Atomic mass of elements. If I have a compound sodium chloride, its molecular weight, I get the atomic mass of sodium plus atomic mass of chloride, whereby the atomic mass of sodium is 23 plus atomic mass of chloride, which is 35.5, and I end up getting 58.5 grams. If I want to calculate the molecular weight of water, I get the atomic mass of hydrogen, which is 1, but there are 2, I multiply by 2, then plus oxygen, which is 12, and I get 14 grams. If I want to calculate the atomic molecular weight of carbon dioxide, I know that the atomic mass of carbon dioxide is 12, oxygen solate is 16, oxygen is 16, so here we get 18, water is 18, then carbon is 12, plus oxygen, which is 16 times 2, I get 12 plus 32, which ends up giving me 44. So this one becomes its molecular weight. So this is how we calculate the molecular weight of a substance. And remember, we said 1 mole. We can say that 1 mole of a substance is equivalent to its molecular weight. Always remember that 1 mole of a substance is equivalent to molecular weight of that substance. So this is what we can discuss. We have looked at what an atom is, what an element is. We have looked at the first 20 elements of the periodic table, how we can look at the valence, the electronic configurations, and the structures of different compounds. We have defined atomic number, valence, isotope, atomic mass. So this is what we call fundamentals, or the building blocks of chemistry. Thank you so much for learning with us. May good Lord bless you.